Okay, so once again, the arithmetic sequences are adding a constant every time. That constant might be positive or negative. So it looks like subtracting when that constant's negative on the quiz. I saw a lot of people miss the negative on the common difference because it was decreasing. Geometric is what we're going to learn about today. Geometric is when we're multiplying by a constant over and over again. That is represented by our zombie problem. We were doubling the number of zombies every day, right? Cell division, right? A cell divides into 2. It doubles the number of cells every hour, every however long it takes for them to double. Those are geometric sequences. And if it's not either of those, it's neither. So let's look at number 1. Is our pattern adding, multiplying, or neither? And it has to be consistent. Multiplying by 4, right. So this is geometric because the pattern is times 4 times 4, and that times 4 means the common ratio R is 4. Number 2, -5, -13, -21. What's happening here? -8, -8. What is that? It's arithmetic. And the D is -8, the common difference. What about number 3? It's neither. This is actually a very famous sequence called the Fibonacci sequence. Fibonacci. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 would be 13, and that continues on and on and on. And the Fibonacci sequence is actually found in nature a lot. Like when you look at nautilus shells, the size of the little compartments inside that spiral of the shell increases with this sequence. And what about number 4? Adding 2, and then adding 3, and then adding 4. That is neither. Okay. So it has to be consistent all the way through. So our geometric sequence formula is AN equals A1 times R to the n minus 1 power. Looks a lot like our chapter 8 equation, y equals AB to the x. But we could start with 0. We could start with day 0, the initial number of cells or the initial number of infected. The sequences don't start with 0, which is why we subtract 1, because the first term will be when r to the 0 power is 1, because a1 is our first term. So any term, an, these still have the same definition, right? If it's a8, it's the 8th term. If it's an, it's any term I want. That's how I write the equation. It's equal to a1 times r, the common ratio, to the n minus 1 power. The nice thing about geometric sequences is we don't have to do any simplifying when we write the equation. If I know a1 and I know r, all I have to do is plug it in. So let's look at some other things. If I wanted to find, we're going to look at these sequences below. We're going to find the next 3 terms, identify that common ratio, and then we're going to talk about how would I use that formula to maybe find the 25th term, or, well, 25 is going to get really big, but, you know, like the 7th or 8th term. So, number 5, take a second, see if you can figure out what the next 3 terms are. Okay, so what is our common ratio for number 5? We need to know that in order to find the next couple terms, right? R is positive 3. We're multiplying by 3. And so my next one is going to be what? What's the next term? 54, 162, 486. Okay. Now look at number 6, 1/2, 1/6, 1/8. Can you find what R is on that one? Yes, R is 1/3. Right? The numerator is staying the same. The denominator is changing by the same numbers as number 5. So my R is 1/3. So my fourth term is going to be 1 over 54, 1 over 162, and 1 over 486. What about number 7? That looks kind of hard. Here's how we find common ratio if we can't see it. Okay? If we can't look at it and automatically say, oh yeah, that's times by 3, then we divide the second term by the first term. Negative 4.8 divided by 4. Do that in our calculator. Yeah, even when it doesn't look consistent, because we're going to see. I got negative 1.2 when I divided that. Now let's divide the 5.76 by negative 4.8. 5.76 divided by negative 4.8. And I also get negative 1.2. So my R is negative 1.2. We can always find that by dividing the second term by the first term. You will have calculators. Okay? And so then my next one, 5.76 times negative 1.2 is negative 6.912. Times that by negative 1.2. And we get positive 8.2944. And then times by negative 1.2 again, negative 9.95328. What do we notice about the sign when R is negative? It's switching back and forth, yes. Now, this is different. When we did chapter 6, our base was not allowed to be negative because of that switching back and forth. It doesn't give us a continuous exponential function. But we're just talking about a sequence of numbers, and these are discrete points. We don't connect them, and so we're allowed to have a negative common ratio. Okay? What if I wanted to find a 10 for each of these sequences? Yes, how can I use the formula to find a 10? So A1 is my 2, right? A1 is 2. R was 3, so it's AN is 2 times 3 to the 10 minus 1. A1, I'm using A1 equals R to the n minus 1 power. My A1 is 2, my R is 3. Now, here's where you guys always make mistakes. Not all of you, but a lot of you make mistakes here. What operation has to go first? Is it multiply and then exponents, or is it exponents then multiply? Exponents then multiply. So exponent has to go first. 3 to the 9th power I have to do in my calculator first. 2 times, it's going to be big, right? 19683. So 39,366. Because I said let's find a 10. Okay, I just picked a number and I chose 10. So what will my... Okay, so we're going to look at 6. My r is 1/3. My a1 is 1/2. Now, we like fractions better than we like decimals. Okay, so this fraction is going to be a little bit complicated sometimes to deal with them, but we've got to get that down. So my formula is 1/2 times 1/3 to the n minus 1. a1 times r to the n minus 1. I don't have to do anything else with that to write my equation. Once I know a1 and r, all I have to do is put them in. Okay, unlike the arithmetic where we had to distribute and simplify. So if I want to find a10 is 1/2 times 1/3 to the 10 minus 1, which is 1/2 times 1/3 to the 9th. I don't want you to do 1/3 to the 9th in your calculator. I want you to do 1 to the 9th, which is what? 1. And then I want you to do 3 to the 9th, which we found to be 19683. So I want you to do 1/3 and I want you to do 3 to the 3rd so that you can keep the fraction on in your calculations. Okay, yep.
Yeah, when I learned when you multiply a fraction with no fraction, apparently it turns into a decimal as an answer.
Well, your calculator will turn it into a decimal automatically. And if the denominator is too big, your calculator won't convert it back to a fraction. So you've got to do it little pieces at a time. And now I can do 1 times 1 is 1. Multiply my numerators. Multiply my denominators. 2 times 19, 683 was 39,366. So a10 for number 6 is 1/39,366. The minute we put it into a decimal, we are rounding it, and it becomes inaccurate. Yes? Well, the numerators. I'm raising this fraction. Oh, sorry. This should be 9s, right? 1 to the 9th and 3 to the 9th. My bad. But that's how we raise a fraction to an exponent, right? We can do the exponent of the numerator and the exponent of the denominator. Yes, I did them individually so I can keep my fraction because the calculators will only allow a denominator of like 4. And so it's not going to convert it back to a fraction for you. Okay? Okay, but if the problem is decimal, you can use decimals, right? So number 7 is a decimal problem. So if the problem is in decimals, you're welcome to use decimals. So my a1 is 4 and my r is negative 1.2. So my rule, my equation for the nth term of the geometric sequence is 4 times negative 1.2 to the n minus 1. N is still 10. We're just finding a10 on these. 4 times negative 1.2 to the 10 minus 1. An is 4 times negative 1.2 to the 9th. Now, because my problem is in decimals, I can just use the decimal. Negative 1.2. Now, I need to do that in parentheses. Negative 1.2 to the 9th. Should that number be positive or negative? It's a negative because a negative to an odd power is negative. So use those self-checks. I get negative 5.15978. I'm going to have to round at that point. Times 4. Negative 20.6391. And it keeps going.
How many decimal places?
3 to 4. Okay, the more the better. The more you round it, if you round it to the 10th place, you're taking away a lot of accuracy, especially as you continue to use that number in calculations. So we like 3 to 4 decimal places. Remember that whether I write A10 or AN, if I'm given that an is a number or a10 is a number, that usually goes into the equation as an, right? So those are kind of interchangeable. This is just a specific number. Okay, so we just did an example like number 8. Write a rule for the nth term. I want you to do number 8 on your own right now. You're just writing the rule, not finding any term. So take a second and do number 8. Let's do number 8. My A1 is what?
6.
And my R times 4, right? Times 4 times 4? Oh. So an is 6 times 4 to the n minus 1. Yeah? That's it. That's my answer. That's my rule. Okay, so I want to write the rule, but I don't know A1. Can you solve the equation to find A1? We're going to plug in 27 for what? AN. So 27 equals A1 times 3 to the 3 minus 1. Go ahead and solve for A1 and write your equation. Okay, so 27 equals A1 times 3 squared, which is 9. The opposite of multiply is divide. So A1 equals 3. Am I done? Did it just say to find A1? No. Find the nth term, so AN equals what? What's my equation? 3 times 3 to the n minus 1. Am I allowed to multiply those together? No. No, no, no. I have a variable in the exponent. Exponents have to come first, so I can't do the multiplication. Okay. Go ahead and try number 10. Okay, let's see. What is our AN? What were we given? Negative 500 equals A1 times 5 to the, what's my N? 4 minus 1. Okay, the number, the subscript, A4 means N is 4, and the negative 500 will be your AN. So that's negative 500 equals A1 times 5 cubed, which is 125. And so A1 is negative 4. Divide by 125. Am I done? No, it asks for the rule. So AN equals what? To the n minus 1, right? Negative 4 times 5 to the n minus 1. All the rules are going to have n minus 1 as the exponent and A1 equal to. All right? How about number 11? If I want the rule, I have A1. I have AN. What's AN? 83. And number 11. And N is what? 4. Can you plug all that in and find R? Yes, you can. Yep. Hold on, we made a mistake with the numbers. That's why you may have gotten stuck. This should be 88. Change that to 88 and your world will all work out nicer. Yes, I apologize. All right, so we're going to plug in what is our AN. 88 is our AN. Our A1 is 11. We don't know R. N is 4. So to the 4 minus 1. Okay. We divide by 11. And we get 8 equals R cubed. How do I get rid of the third power? I take the cube root. So R is plus or minus. No, never mind. It's not a positive. It's just 2. But if it was an even root, we could get a positive or a negative. And so then we can have to write two rules, one with the positive and one with the negative, because we don't know which one it is. It could be either, given the information you have. If you knew one of the terms in between, if you knew A3, whether that was positive or negative, then that would tell you. But you don't know. Okay, so my rule is AN equals 11, my A1, times 2 to the n minus 1 power. Okay, so here's number 12 is the one where I have two terms. We use the system of equations with the arithmetic sequences, and then we had a shortcut. We don't really have a shortcut on this one. Okay, so we're going to write our two equations. Let's see, A2 equals negative 10. So that's negative 10 equals A1 times r to the 2 minus 1. And negative 6,250 equals A1 times r to the 6 minus 1. I have two variables, but I have two equations. So could this be negative 10 equals A1 times r? And this could be negative 6250 equals A1 times r to the 5th. Yes? I just simplified my exponent so far, right? Now I'm going to solve. We're going to use substitution method. And I'm going to solve for A1, so I'm going to divide by r. So A1 equals negative 10 divided by r. It's not as bad as it seems. Now I can substitute negative 10 minus r into A1. Negative 6250 equals negative 10 over r times r to the 5th. I just substituted. Now, can I simplify my r's? Yeah. Essentially, it's r to the 5th divided by r gives me r to what power? Negative 10 times r to the 4th. Okay, because that's going to eliminate one of those r's. And now I can finish solving. Divide by negative 10. Get 625 equals r to the 4th.
And then do you take the 4th root?
Yes, we take the 4th root of that, plus or minus the 4th root.
Plus or minus
Because it's even, plus or minus 5. So we're going to make two equations. If I plug in a positive 5, okay, so for r equals 5, A1 is negative 10 divided by 5, which is negative 2. Yeah? So my equation is AN equals negative 2 times 5 to the n minus 1.
Was that the rule?
The rule, write the rule, right? That's ultimately what it asked me for, write the rule. Now what if r is negative 5? How does that change A1? Negative 10 divided by negative 5 is a positive 2. And then my equation is AN equals positive 2 times negative 5 to the n minus 1. Right? Because I don't know enough information to know whether it's going to be the positive or the negative 5, because I don't have the terms in between to tell whether they've actually changed sign or not. So I have to write both possible equations.
Okay. So would you have two answers?
Yes, I have 2 answers. And that's only when I'm taking the even root when I'm solving for r. Only when I take that even root do I have the 2 possible answers. Okay, if it's an odd root, I only get 1.